Yep, works good. Okay, coming about homework. So, you've learned pretty much what I expect. It is critically important in this class to not fall behind. I've mentioned that before. It is critically important that when I send you home with a packet like this, that you really give it a genuine, honest effort to get through it. Okay? That you come back, you do the best you can. Okay? I was really pleased with a lot of people that when they reported on this, the first day back, they showed me their work, they gave me the tour, and I could see blank spots, but I also noticed that they didn't quit. Like they just kept going. And this one does not make sense to me, maybe the next one will. Because they're not in order, they're just random. That's how all the packets are usually. So you keep going, you come back, you report that you made an honest effort to get through it. When you do that, I pay you some extra credit, which is of significant value in this class. It adds up to be a good amount. So you get that, right? The other thing I do with homework is eventually you do get a score in Skyward. Okay, that's where the 10% of your grade comes from. But having done this for a long time, knowing that high school in some ways is worse than college. In college, I would go to a class at 8 in the morning, and then I would have 2 hours when I would not have a class. So I could literally sit down in the library for those 2 hours and start working on the homework just right away. It's like perfect. That's how I would set up my schedule, to kind of have blocks of time. So college was nice that way, in that there were big chunks of time in the day when you could work on it. High school's tough. Like you have to go to school all day and blah, blah, blah. So anyway, on the homework, I always check for this. I always walk the room to make sure you're not falling behind. But as far as what goes in Skyward, I usually give 1, 2, sometimes even 3 more class days before I will ask you to tell me that you've actually finished it. So I passed this. It says buff. So it's the buff homework. So this is the very first one we did. It's been a while since we worked on that. So this packet is this clipboard, okay? Here's the critical part. Listen close. Okay, when you get the clipboard today, you should be thinking this, and thinking of the buff packet. If you really have done every problem, you've checked every problem, it's good notation, you're like really comfortable, then you put a check mark. So you don't put a score. So don't put any scores on this. Just put a check mark. Okay? Listen close. If you honestly are sitting there thinking, there were 3 problems I didn't really do. Like I just didn't know how. I just have not found time to get help from either me or from someone else to get really comfortable with all of the problems in the homework. Don't put anything. Just leave it blank. Okay, if you come to me a day or 2 or so, relatively soon, you come and say, hey, when you passed the clipboard, it reminded me that I actually had not finished the buff packet yet. I still had a couple of questions. But since then, I've had time to talk to me, or I've talked to a friend, and I feel 100% finished. I feel really good about it. I will change your score in Skyward from 0 to 10. Okay? Simple. What you can't do, though, is come to me with a pile of homework, like this, and say, oh, I have all my homework finished now. Then you only get half credit for it. Do you hear the difference? Okay. Questions about that? So again, just check marks here, indicating that you really have finished it 100%. You feel really good about it. Okay. So pass that to the room. Grab the yellow. Go to problem number 1. Okay, I mentioned to someone this morning who I was helping that, again, I'm not trying to teach you procedures, because procedures won't help on the AP test. So I'm trying to get you to think in a more open way. For example, I have seen an AP question that doesn't have any of this information. So I've kind of structured this more like homework, where I give you a little more structure to help you get going. But the AP test, I have seen a question that was almost word for word identical. They simply give a function, and they say identify the x-axis location of the discontinuity, or discontinuities. That's the entire question. But I've only seen that question once in 60 years of studying the AP test. Okay? Like I've studied lots of old tests. So you have to be able to prepare yourself to think openly, not to memorize this problem. So here's how I would think of it in an open way. I'd read and notice there's a function. I'd see the word discontinuity. My first thought would be, hey, based on the pink packet, I'm pretty solid now understanding that if I can write a function in factored form, it's usually a lot easier to understand. So without doing anything else and even knowing exactly why I'm doing it, I would factor the function they gave me. So let's do that. Okay, make sure you use the equal sign. So this is f. Over here, I'm going to create a different version of f. So I write f of x equals. See, the top's going to be x plus 2, x plus 3. And the bottom, x plus 3, x subtract 2. Okay, the next line you don't have to write on your paper. I write it for clarity. So I'm going to have x plus 3 divided by x plus 3. And this will be x plus 2 divided by x subtract 2. And these are being multiplied. So, question. Awesome. Okay, so I've got my function written in a way that's a little easier to see. Right away I notice this, and I notice that this is, like, what is this usually equal to? 1. Are there any exceptions for when that is not equal to 1? So hands, who knows the exception? When is this not equal to 1? Hands, please. Who knows when this is not equal to -1? Hands. Okay, give yourself a point if your hand is raised. Then put them down. Okay, everybody look at me. Keep reminding yourself. This is a formula. Hands up. What's its fundamental purpose? I'll pay everybody. What's the fundamental purpose of the formula, Mary? So how many knew that? Point. It's to find all the x, y pairs. Hands up again, everybody. How many different x's can you plug into this formula? Hands. How many different x's can you plug in, Sophie? How many knew it? Point. So, just say yes or no out loud. Is this formula exactly the same?
Yes.
Is this formula exactly the same?
Yes.
Okay. Keep going for a second here. A lot of people would write this. Okay, on the AP test, if you write purple, purple, blue, the colors don't matter, that's just so we can talk. If you write purple, purple, blue, when you write the blue statement, you're in danger of losing a point. Who knows why? Show me your hand. I'll pay everybody. I'd like everyone to know, so talk to each other, and hopefully everyone will understand. You can raise your hand. Like, why am I in danger of losing a point when I write that? Who knows? Hands. Who's ready to talk? Let's go, Julie.
You didn't explain how you got rid of the x plus 3 divided by x plus 3.
Nicely said, Julie. Nicely said. Nicely said. We went with this nasty, like we just canceled it, right? It's disappeared. This is the correct formula for f. So is this. This is not the correct formula for f. Tori, go ahead.
Because then you don't know that you can't have -3.
Perfect. If you write this formula for f, and you also write the following, nicely done, Tori, then you're okay. But otherwise, it's really not equal. Okay? On the AP test, they're looking to see if you know what equal means, that you use it properly. So be a little cautious. It's borderline. I'm not sure they would actually take away a point, but it's a little borderline.
I know we get negative, they're just like,
Oh, I don't know.
this wrote that.
Oh, right here. Because here, if x is -3, what does this become? 0 divided by 0. What is 0 divided by 0 actually? Undefined. So this does not equal 1, as Tori said. There's 3 points for Tori. There's 4. Can't stop saying your name. As Tori said, this is equal to 1 unless x is -3. So this formula only works if x isn't -3.
That's just an extra value.
Yeah, good question, Justin. Please.
Could you also just do x plus 3 over x minus 2 times 1? Is that like a number?
Oh, like this?
Yeah.
Good question. 2 points for Elena. Not unless you have this.
Okay.
Yeah, just putting the 1 isn't sufficient, because the idea is for you to not forget, right, that it's only equal to 1 for every x except
Okay.
that one. Perfect. Okay, look. So again, back to the AP test question. It said identify the x-axis location of the discontinuities. So I factored, once I got to here, and honestly on the homework, I probably would not have written this. I don't really need it. I know right away that I have a removable discontinuity because I've memorized what, like one way to get a removable, there's more than one way, but one common way to have a removable discontinuity is this. When you have a factor in the numerator, which matches a factor in the denominator, and there is a value of x which will cause this to become 0 over 0. So here's a little thing I would memorize. If you end up at some x where you get 0 over 0, memorize that that is a removable discontinuity. There are other ways to get removables, but that's a common way. Question. So please.
So you're saying if there's any possible way for a function to get 0 over 0, it's a removable.
Correct. 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 So right here I go, oh, there's a removable when x has a value of -3. It has to be, it's really more what Justin said. If there is an x, which will cause the numerator and the denominator to become both 0 for that x, that's removable.
So isn't any function that could be undefined? It's just 0 over 0. Like the top and bottom have to be able to be 0 at the same time.
2 points for Carson. The other way for the function, there's other ways, but another way for the function to be undefined is for the top to still be a number, but the bottom to be 0. That's not a removable. That's a vertical asymptote. There are also other ways to have vertical asymptotes, but that's the most common. So not numerator over 0. This is my little symbol for just any number. Just any value divided by 0. So. Other questions? Okay, so I found the removable. You need to memorize something. So memorize. Only piecewise functions have jumps for our class. There might be some exotic functions that you would study elsewhere, but not here. So only piecewise have jumps.
So would there be like a vertical asymptote at +2?
So Chris is saying that nicely. I look over here, and Chris has memorized that, hey, if I find a value of x, which in this case is 2, and I plug in 2, let's see, this would be, say it out loud, what's it? 5. What's this one?
4.
Okay, so the top's not 0. 5 times 4 is 20. The top's 20. But the bottom, this would become 0. 0 times whatever that is will be 0. So yes, there's a vertical asymptote at x equal 2. We're getting this happening. We're getting a number divided by 0 when x is 2.
What's the case times second?
So piecewise, let's give points to the whole room to answer Justin's question. So once again, just raise your hand. You can tell me what's the purpose of this formula. Hands up. What's the purpose, Ashley?
To find x and y value.
How many knew it? One. So that finds all the x and y. Hands up again. How many x's can you plug into this? Hands, Kennedy. And just raise, give yourself a point. Okay, so look at me. So the graph is the front of the room. So this formula can have all these different x's, and you get different y's. You with me? Okay, piecewise is super simple. Instead of having one formula for all of these x's, you have 2 or 3 or whatever.
So
Separate formulas for different sections of the graph.
So that's like what we did.
One
on
second,
the-
go ahead, go ahead.
Oh, sorry. That's what we did on the butt paper, right? Those ones are piecewise?
Right, so like right here, Justin and also Sarah,
On like 3.
like that.
Yeah.
So that's a piecewise. That'll have a jump, possibly.
Possibly is the key word,
Yeah.
not guaranteed.
Okay.
Right, so jumps for our class only occur in piecewise. Doesn't mean that all piecewise have jump. Good question. Pretty good? So is everybody okay to hear? Awesome. Okay, so we found the discontinuities. The homework then says to find the following limits. So I look here. I'm supposed to find the limit as x approaches -3. Okay, you have to check left and right. So I have to check a little bit less than -3, a little bit more. But I just look over here and say, well, pretty easy now. If x is almost -3, say it out loud, what's this? So raise your hand, let's just do every raise your hand on this one. So if x is almost -3, raise your hand if you know what this is. Just raise your hand, I'll pay you. If x is almost -3, Holly, what's this?
1.
So Holly votes 1. How many agree with Holly that this is 1? Point. How many thought it was a different thing? So you thought it was?
I thought it was because it's approaching 0.
Yeah.
No worries. Point for that. You else have a different idea? Some people said close to 1. It's actually exactly 1. Because the top and bottom are identical. So no matter how close x is to -3, it doesn't matter. The top and bottom will be exactly the same. So exactly 1. There's only one exception. Hands up again. What's the exception? Come on. What's the exception for this, Tim?
If x is -3.
If x is exactly -3, this is undefined. How many knew it? 1. Okay. Question? Perk. So we're doing the limit. So we know when x is close to -3, this is 1. Now I just look at this. So let's see. Close to -3 plus 2. What is it? Close to. Louder? Okay, so this one's not exactly -1. This one's close, but so close to -1. So I'm going to just write that down so I don't have to remember in my head. And then when x is close to -3, this is going to be close to -5. So the limit left and right is 1/5. Question? Perfect. Hands up if you know this. Show me your hand. Let's go, Abby. How many do it? Point. Very cool. Something else to memorize. Make a copy of it. So you need to memorize this. Okay, first of all, these are listed in order for a reason. But before I check any of these, I do need to mentally think, if it's a vertical asymptote, the limits are always infinite. So this does not apply to a vertical asymptote. Vertical asymptote, the limits are infinite, they're unbounded. But if it's not a vertical asymptote, the first thing I would check is, are the left and right limits the same or are they different? You did this on the buff packet. If the left and right limits are different, that's a jump. If the left and right limits are the same, like we saw here, left and right are both 1/5, and that's different than f of a, like here, that's confirming that it is a removable at x equal -3. If left and right are the same and they match the middle, then the function's continuous. So that's just reviewing from the buff packets. Questions? Must have that memorized. Please, Tori.
Wait, I'm a little confused how you got 1/5 when it's approaching -3.
No worries. So I will keep track of your points. You're going to talk with me because if I can get you talking, it will click. Is that okay? So I'm trying to figure out what happens when x is almost -3. So are you okay that we use this?
Yep.
Awesome. What's this equal to?
1.
So there's a point. When x is almost -3, what's this, Tori?
1. Or -1, sorry.
You go with -1. So this is really close to -1. What's this when x is almost -3?
-5.
-5. So the top's getting really close to -1. The bottom's getting really close to -5. So I'm getting close to 1/5. And then it's the negative over negative is positive. Is that good?
Yeah.
Put down 4. Anybody else?
So these
Please,
words
Jason.
right here are just basically what we did on day 1.
Yes.
Okay.
Yeah, I'm just putting it up here, informal, kind of like you can see it, just to remind you, you gotta have this memorized. So. Perfect. Just give a moment for people to finish in the notes. Okay, now they ask us to find the limit as x approaches 2. Tori just earned 4 points. Somebody would like to have a similar bulk earning. I just need a volunteer to do the same thing I just did with Tori. Carson, here we go. So we want to figure out what's happening when x is getting close to 2. So I look at this. Change color here. So what's this going to be when x is close to 2?
1.
So that's 1. What will this be when x is close to 2?
It'll be approaching 4.
So if that top's getting close to 4, 10. The bottom's kind of interesting. If x is slightly more than 2, what's the bottom, Carson?
It's going to be close to 0.
Will it be a little more than 0 or a little less?
A little bit more than 0.
A little bit more. So the bottom's going to look like this. So let's write this out better. So if x is getting close to 2, but x is slightly more than 2, the y value is going to start looking like 4 divided by something like this. Raise your hand if you feel 100% confident in this thought, that this makes total sense to you. Show me your hand. So payment for the room. We want to talk about payment points for all of you. We want to talk about it.
Something where 2 negative would be like...
4 for Carson.
There 2 negative would be 4 over like through like how do you write that?
So we'd say 2 negative. This is not official math. This is just so you can see how I'm
Yeah.
thinking. You get 4 on the top.
Then 0.9999.
No.
Or
Close.
Because it's close to 0. But
Close to 0, but it's slightly negative. So it would be this. Okay, be honest, show me hands if this makes perfect sense. So when x is just a little bit less than 2, so if you take two values, and you have slightly less than 2, like 1.99999, and you subtract 2, you're going to get just barely negative. Show me your hands. Point. So just say it out loud, please. Is this value positive or negative? Say it. Louder. Positive. How about this one? Negative. Awesome. You take a number, you divide by something tiny, you get something big. So this is headed towards infinity. This one's headed towards negative infinity. That's why when you have a vertical asymptote, you get infinite limits. Okay? You be with me? Now, that would cause this to be non-existent because these two are different. But honestly, there's some controversy. Some math professors say, oh yeah, this limit's non-existent. But other math professors just say these limits are all unbounded. There's no limits anywhere. Like y is just getting either really positive or really negative. So in this worksheet, if you look in the back, I believe I just used the word unbounded. Okay. Either way is really acceptable, so there's nothing to stress about.
Undefined or unbounded?
Undefined is used when we're finding a value.
I meant like not like it's
Yeah.
the other
You mean like non-existent?
Yeah, that.
Yeah, so kind of, all these words have subtle differences. Non-existent, unbounded, pretty similar, although slight difference. Unbounded literally means the y-coordinate is growing forever. Doesn't stop growing, either positively or negatively. Questions here? Please,
So
Justin.
basically what we did with like the infinity and negative infinity is like day one you're approaching from either side. Is that what we're trying to point out? Cal?
Perfect. Hands up, you know it goes here. Show me your hands. Like everyone to get this one as well, so talk to each other until everyone's hand is raised. So the simple answer. Why did you need to for the value of the value of the function? Hands up. Who's got it? Show me your hand. Dawson.
Undefined.
Everybody agree? Point. Okay, any questions on number 1?
Instead of putting unbounded, could you put positive, negative, infinity?
I've never seen that be an answer.
Okay.
I have seen, an answer be, well, let's see. I've got this vertical asymptote. On one side, the y-coordinates become very positive. On the other side, the y-coordinates become very negative. So I've seen non-existent be an answer, but never listing both. Questions? Justin? You're good. Carson?
So would that graph just look like 2 points going like this?
Exactly.
Okay.
Yeah, at x equal 2, the graph, when x is slightly more than 2, the y-coordinates head upward. When x is slightly less than 2, the y-coordinates head downward. Cool. Next thing. Go to number 2. Work on number 2. I'll walk through and stop me if you have questions. You're. Remember, once you get the function factor, you notice matching properties. So then you have checkpoints. Cause this to zero. So that's the reason. Then I notice another factor. Getting a factor. So what X makes this what is 7 here? 7 here. It's 0, whatever. Just multiply it. So
Yeah, what are you talking about F equals -4?
top.
No, it's not that one. Because this one's infinitely close to 0, but it's not. That's why I'm so confused.
So whenever I get top,
I guess you're right. Or just would it be like, what's it, unbound?
Why would I?
Because wouldn't it be unbound like this? That's X. And that one's just 0.
No, there is. That's right. Then if I choose
That one.
we'll grab.
Because that would be 0. Yeah.
What did I see?
Because if it's divided by 0,
It's a y value.
no, if you're dividing like 11 by 0, not 11 by 0. So if you're dividing it from 0 to plus, then yeah, so I was off.
In this case, yes.
Really, really close.
So when X gets close to -4, close to -4, what's the close to -4
But it does get infinitely close.
So when the top gets close to 0, the bottom gets close to the number, it's just getting close. So what's different between this and this? Because what happens is that precisely that's true, it's undefined. That one's about how this is
That's the same as this.
and last time is precisely.
But wait, wouldn't it be getting infinitely small? I'm trying to find ways. You wouldn't get
So if that was on bottom, it's the point.
Like there's certain entities we're on other entities that we don't overcome, we just thank you very much. Not quite as good as before. Put your stuff up.
I understand like everything I have to do, but exactly when it comes to like figuring out the
Hey, look up. I just come Look up. Okay. I'm going to go through it. The point of going through it is not for you to check your answers. The answer's in the back. You can check your answers. The point of class time is to check your thinking. So you need to concentrate heavily to make sure that you listen carefully to what I say, and you're kind of checking, hey, is that what I thought, or did I think something different? If you thought something different, just raise your hand and we'll just talk. So anyway, same thing, I would factor again to kind of see what's going on. So we end up with F equals, and I'll take a little bit of a shortcut here. So we'd have x plus 4. When I factored the bottom, I also found a factor of x plus 4. And on the top, we'd have another factor of x plus 4. And on the bottom, the other factor was x subtract 7. Any questions today? So immediately I see this catches my eye. That looks like 1, except if x is equal to -4. It isn't. So that fits the definition of a removable, where I get for x equal -4, I have, so let's write it down. So for x equal -4, f of x, so that means f of -4 ends up being 0 divided by 0. That's a removable discontinuity. So that's what I'm thinking. You need to have that idea memorized. Okay, questions?
Do we need to write that down, or can we just?
You don't need to write it. That's just so you can hear what I'm thinking.
And then
just see what I'm thinking. So I got removable at x equal -4. Points for the whole room. I put none there. How do I know to do that? Hands. I just write it down. So A's, don't say it. A's lead, right?
Yeah.
Go ahead.
It's not a piecewise function?
Yeah, not a piecewise, so no jump. We knew it. Point. Then I come back over here and I say, in factored form, this catches my attention because at x equals 7, let's see, so that means f of 7, this will still be 1, this would be 11, this would be 0. Oh, the whole thing? That's going to be some number, 11 over 0. That's a vertical asymptote. So vertical asymptote at 7. For our class, I have to search my memory. The only other way I can recall having a vertical asymptote in our class is some sort of function involving natural log. Okay? Like I don't recall any other way to get a vertical asymptote other than factor on the bottom, which results in number over 0. Or I do know that natural log functions can have vertical asymptotes. Question? For a different reason. Okay, so we're good to there. Need to find the limits. So let's see. Need to check left and right. Well, when x is close to 4, say it out loud, please. When x is close to 4, what's this? Say it. 1. We talked earlier, right? It's exactly 1. So close to 4, the top here is close to what? Say it. 0. The bottom's close to negative 11. So I'm getting close to 0 on the top, close to negative 11 on the bottom. No big deal there. That's just close to 0. Question? Show me your hands. Who knows what this is? Let's go, Abby. How many knew it? Point. Questions? Oh, please.
Sorry, can you just go over that?
Huh? So, are you good with this one?
Yeah.
Awesome. So at exactly negative 4, what's this?
That's going to be.
Perfect. Because 0 over 0, you get that.
Okay, yeah.
No worries. So undefined, okay, I like to joke that the math people, whoever they were like sitting at a table and they're talking like, 0 over 0, what do we do? What do you think? Kayla's like, I don't know. I don't know what 0 over 0 is. Lizzie, what do you think? Beats me, I don't know. Josh speaks up and says, we don't want to tell everybody we don't know. So let's say it's undefined. That's how I think of it. So like if you don't know what this is, and you multiply by something else, what do you have? I don't know. That's fine. What does that help?
Yeah.
Good job, Olivia. Anybody else? Cool. Okay. X equals 7. When we get close to 7, it's the same thing that happened last time with the vertical asymptote. We're getting limits that go towards infinity. So I believe the answer in the back just says unbounded. F of 7, undefined. Question? Please.
So what does like unbounded mean again? Infinity?
Yes. Yeah. Unbounded means the y-coordinate grows without limit, without bound. It never stops growing. So it either just becomes more and more positive forever, it's unbounded upward, or the y-coordinate just goes down forever, it's unbounded forever. Undefined means there isn't a point. Question, Sydney. Next thing. Go to number 3. Okay, please memorize the following. If you need to take a moment to write it down, write it down. I've already told you, for our class, jumps only occur in piecewise functions. For our class, jumps only occur in piecewise functions. As Justin mentioned, that doesn't mean there has to be a jump, but the only place you're going to find them is piecewise. Second thing to memorize. We talked about how if the front of the room is the graph, a piecewise function will have different formulas for different sections of the graph. Okay? Where we change from one formula to another, I call those the transitions. So in this piecewise function, there's only one x-coordinate that I would consider to be a transition. X equal 3. Very good. That means if there's going to be a jump, it will only occur at x equal 3. That doesn't mean there is a jump, but if there is, that's where it will occur. Okay? You need to write on your homework the following, because you have to prepare yourself for the written section of the AP test where they would require you to use limit notation. So I remember from this little piece here, that you all wrote down a minute ago, that if there's going to be a jump, the left and right limits are going to be different. So in my work, as I prepare for the written section of the AP test, that's what I write. I say the limit as x approaches 3 from the left, and then finding the limit of f, so I just put f right here. And please talk to each other and raise your hand when you're comfortable with this answer. Go. So work together. Raise your hand when you know what those
You get 7. Like you get rid of that scores to 7. How do you add?
That's like 2.9.
Yes.
Who's got it? Raise your hand.
Let's see what the positive.
Okay, first, a related question. Please raise your hand if to answer this question you are using the bottom equation. Show me your hand. Who's using the bottom equation? Good, everyone give yourself a point. Just making sure somebody last period used the bottom one. The top one is the correct equation because x is less than 3. Say the answer out loud. What'd you get? Show me your hands. You got 7? Point. Now I find the limit from the right. So do that. Make sure you write down the limit in your notes on your homework. Raise your hand when you have this one, please. Show your hands. Let's go, Carrie. Who agrees with Carrie? Point. Okay. As soon as I see that, I know something right away. Who knows what I'm thinking? Hands. As soon as I see that, I know something right away. Who knows what I'm thinking? Let's go, Luke.
Is it that there's no jump?
No jump. For a jump to occur, it must be piecewise, and the left and right limits have to be different. How many knew it? So then, Lizzie's on the right track. I remember the definition. Oh, please.
So is this basically like, or at least this question, is this like the day one homework, except we don't have to write any of it down, it's just there and it's figured out?
There is a ton of overlap, absolutely, absolutely. There's a teeny bit that's perhaps new on this, but not a lot.
Because it's like, I mean, we had to write jump when we were before that, and then we had to fill out all this stuff. So it's just-
Very good. You're right on the right track. Perfect. So then, I remember that I need to check what's happening exactly at 3. So, hands up. What goes here? Come on. What goes here? So, Laura?
2.
How many agree? Point. So now you check the definitions. If the left and right are the same, but the value of the function itself is different, that's removable. So, question?
So removables when all 4 are not the same, right?
So, kind of different ways to think of it. These two tell me that this one,
Yes.
and again, this is from the above,
Yeah.
that this one is the same.
Yeah. And then it would be undefined if they didn't match.
It would be non-existent if they didn't
Yeah.
match.
But now, so the limits are the same, but the active
Yeah.
is different. That's why.
That's removable.
But it's basically the same exact limit.
Yes, they're all the same, then continue. Okay, right here, vertical asymptote. By inspection, I know there are none, but you need to know why I know that.
Is that because like from x to like when x is -3, it's going on forever, and then exactly 3 is like, so you know there's always like it's just gonna keep going on pretty much.
What you're talking about is different, Josh. You're talking about the fact that as I look at the graph, I can have x coordinates all the way from negative infinity all the way to positive infinity. That's the x coordinate. That's unrelated to the vertical asymptote. Just hold on a second. Let's go to Mary.
Is it because when it says x equals 3, it gives a y coordinate?
points for all these. I keep track of how many times I say your name, Maren, but not really. It's okay. Like it's like we've got all these points, right? And at x equal 3, yeah, there's a point at 2, but that's not a vertical asymptote. Like, Charles, why do I know there's no vertical asymptote?
There's no value that's going to make the denominator 0.
Yeah, look back here. Hey, he's got it. Look. Now, Charles is right. We talked about how the vertical asymptote occurred at an x-coordinate where the y-coordinate became. Remember, f of 7 means y-coordinate. We talked about that on the buff packet. So when the y-coordinate becomes a number divided by 0, that's a vertical asymptote. The only other case I can remember for our class where you have a vertical asymptote is functions involving ln. But there's no ln here, and there's no way to get a bottom. There's like no denominator. The denominator is just 1. So that's why no vertical asymptote. You don't need me to talk through that again. Like, you have to be able to look at the function and say, I recognize. Please.
I was confused.
You're good. So we'll do what we did with Tori. I'm going to talk with you, and I'll keep track of the points. So what causes a function to have a vertical asymptote as best you can remember?
Isn't it just it's kind of where it kind of cuts to on the y?
You're doing great. Visually, you're remembering that the graph will go like this, or the graph will go like this, or sometimes it goes together like this, okay? That's correct. But you have to remember numerically what can cause that. Numerically what causes it is when you end up with an x-coordinate which makes the function's y value become some number divided by 0. Okay. So right here, we have a formula for finding all the y values.
Yeah.
So this formula can be used to find y values for lots of different x's.
Yeah.
Can you find any x which will make this formula become a number divided by 0? The answer is no, because there's no division.
Yeah.
Like, there's nothing being divided here.
Yeah.
So there's no way to become number divided by 0. There's no way for this to become a number divided by. So that's why I know if I can't have number divided by 0,
You can't have.
and there's no ln, I can't be that. So,
Alright.
good question, Chris. Give yourself form. Please.
So basically, if it's a piecewise function, it can't have a vertical asymptote?
Let's pause for a minute. I want the whole room to answer that. So, 2 points for Justin. Raise your hand if you can answer his question. He said, if it's a piecewise function, it can't have a vertical asymptote. Show me your hand. I want to know if that's true or false, and a reason, of course. Strike by them.
Does it no because like sometimes there can be a hole in the graph, or
Keep talking.
like in a piecewise function there can be like a removable discontinuity?
In this case, he's asking about vertical asymptote, but it's the same idea. It's the same idea. Piecewise, go ahead, I can talk to you.
If you have a fraction one that has a denominator that would have a vertical asymptote and it passes it over that x, where the vertical asymptote would be it can still pass.
It's perfect. Yeah, remember, look, 2 for Abby. And Kylie as well. Look, piecewise, look at me. Look. Okay, perfect questioning. But sometimes you can tell from the question that you're falling back into an old bad habit of like just trying to memorize things without making sense of the idea. Okay? Somebody pick up a couple of points and just explain to the class, what's a simple way to think of what piecewise means? Please.
It's like breaking the graph up into like multiple different functions. Like
That's why they call them pieces.
Yeah.
Keep going.
And so like it'll state like from here to here, it follows this trend, and then from here to here, it follows a different trend.
Pause right there. It's perfect, Carson. Look. Perfect. You got the graph. Instead of one formula for everything, just have multiple formulas. So if a formula can have a vertical asymptote, a piecewise function can have a vertical asymptote. Simple. Paul.
So there's nothing being divided, there is no vertical
Right.
asymptote.
Unless ln is involved.
Unless I want that.
As far as I know, if I think of another exception, I'll let you know if I can't think of it.
Could just a piece of the function just have a division? In it?
Right, that's perfect, Chris. Perfect. right here, like look at this one. You've got, come on. You've got 3 different pieces. You've got a formula for whenever x is less than 1. You've got a formula for when x is between 1 and 4. And you have a formula that's for when x is greater than 4. Well, if any of these pieces happens to be a formula where you can get divide by 0 for that portion of the graph, you could have a vertical asymptote there. Other question? Please.
So when you ask, like, how do you know that I don't have, like, a vertical asymptote on this one, I thought it was just, I don't know if this is right, think of it, but I thought just because every x had a y coordinate, that there wasn't a vertical asymptote.
That would also guarantee it, because a vertical asymptote would mean that at a certain x, there is no y. That could have been, like not having a y isn't quite enough, but no, that's good logic, Carl. It is. Please.
Is it possible for piecewise to have, like, on the one we were just barely on, it had like from 1 to 4, and then at some point there was a greater than or equal to. If there is no greater than or equal to, could that count as a vertical asymptote? Like if right there,
There was no equal.
It's just greater than 1.
Gotcha.
Could like that point at 1 be a vertical asymptote?
No. Good comment though, Carson. That would be a missing point. That would be a discontinuity. But vertical asymptote is very specific. It occurs at an x value where the value of the function specifically becomes number divided by 0. So if there's no equal sign here, then at x equal 1, there just isn't a point. There just isn't one. Different than a vertical asymptote. Good question, Carson. Justin.
Do you think we could do one that's like on 13 that has like other variables?
Soon. Good question. Okay, next thing. Go to number 20. Okay, as Justin noticed, starting at problem 13, the instructions change. If you look at problem 13, there's a header instruction that says something like this. For the functions shown, determine the values of a and b, which will make the function continuous. Okay? This is another really good example of how you have to work on the AP test. You don't memorize procedures, you have to think, okay? Like you have to literally learn to think. So here we go. Here's a function. Here's my formula. I don't know what a is. A is some number, 5, 10, something. But I've got to find a so that this will be continuous. So if I'm taking the AP test, I'm trying to think how you will think. What should be coming to your brain is, wait a minute, what does it mean for a function to be continuous? And you're thinking, oh, I know the definition. Like oh, wait a minute, I know even better. I know that I did all these problems a long time ago where I dealt with continuity and removals, and the one thing that always helped was factoring, like always. So before I do anything else, I'm like, let's get this in factored form, then maybe that will help. So this is how you solve problems on the AP test. You don't do it by knowing what to do. You do it by recalling something that you're pretty sure is going to help, and you start there. So let's see, f of x equals, well, it's really not going to be f because it's all that thing. So I don't want to write f of x equals, that's wrong. So I'm just going to factor that. So I'm going to get 2 x minus 7, x minus 3. Bottom's going to be 4 times x minus 7. Now I can put equal, because this line is going to equal this line. and I break up the factors, questions from anyone? I believe factoring helped immensely. Raise your hand if you know why I say that. Goal of the problem is to figure out the value of A, which will make the function continuous. To me, factoring made a huge difference. Who knows why I say that? Show your hands. Come on. A few of you. Let's go, Kenny.
Because it makes it easier to, are we finding the Y? Your X.
So this is my formula for finding, well, actually, this is my formula for finding every y coordinate of the function except x equals 7. Precisely at 7, the y coordinate is going to be whatever a is. So that's true. That's not really why the factoring helps. 2 points though. Why do I say the factoring makes a huge difference? Let's go, Clark.
It shows
Dang,
that there's,
Charles.
it shows that there's a removable X.
That's the key. Like when I factor, I can see the discontinuity. There is a removable discontinuity at x equals 7. Like I can see it. How many saw it? Point. So I'm thinking, hey, if I want to make this thing continuous, I've got to somehow take care of that. So next thought I had was, well, let's see. Continuity has everything to do with like the left-hand limit and the right-hand limit. So let's go play with that. So I write down on my paper, limit as x approaches 7 from the left. So raise your hand when you know what this is. Feel free to talk to each other. Just raise your hand when you have it. What's the limit as x approaches 7 from the left? Feel free to talk to each other. Raise your hand when you have it. Who's got it? Show me hands. Show me hands. Who's got it? Ashley, what'd you get?
2.
So Ashley says the limit as x approaches 7 from the left is 2. Please go like this if you agree. Give yourself 2. Cool. Changing it up. Stupid. Let's do this. Oh yeah, that's from the left. Let's do it from the right. Show me your hands. What do you got? Who knows this one? Limit from the right. Let's go. Sydney?
2.
Sydney votes 2. How many agree with Sydney? Point. So now what do I do? This is how the AP test feels. I'm serious. Like you're like, okay, I factored, that helped. I know that being continuous means I got to find some limits. I did that. Just got to keep searching for information in your head that's related to all this, and then you'll unlock it. Like, so now what? Like, what's the goal of the problem? Like, the other thing you do on the AP test all the time, I refer to it as you like zoom in, you get a really close look at something, and then you zoom back out. So we zoomed in, we looked at what's happening really close, and we found this information. We have all this information. You've got to remind yourself of the goal of the problem. Somebody remind the class, what's the goal of the problem, Calvin?
Well, the goal of this problem? Make it continuous.
To make the function, don't say it, but to make the function continuous. It's all right, I'll forgive you. We're supposed to find the value of A, which will make the function continuous. So now what do I do? Please, Sydney.
Would it be helpful to find like the vertical asymptote?
So is there a vertical asymptote?
I guess that's true. Is there?
That's a good question. Help her. No, you're doing great. Really. I've said your name twice already. Hands up. Is there a vertical asymptote? Show me hands. Who knows? Who knows? Who knows? Is there a vertical asymptote? Garrett.
Yes.
So Garrett says yes. How many agree with Garrett? 2 for Garrett, but no, there isn't one. Okay. It's all good. Look.
Don't say that.
It's all good. Hey, guarantee you, like another compliment to Garrett and more points. That's 3 so far. No, really, your willingness to just speak up and say, there's no other way to say it. There just isn't. You know, I can go, well, there maybe is. That'd be all wrong. You'll be all confused. So it just isn't. You know? How do I know there isn't one?
There's no way you could get a number over 0.
Right. This is going to cause 0 divided by 0 at x equals 7. There's nothing yet. There's no other factors in the denominator which can cause the bottom to become 0, other than the one that's causing the removable. Okay.
So what you're saying is the other 2 functions don't have anything to make 0.
On the bottom.
So if all 3 of them could go to 0, would that be?
Then you could have a vertical asymptote.
So if the 2/4 and the x over 3 minus, if those both denominators become 0.
You could have a vertical asymptote.
Okay.
Here's a huge hint. Look at me. Look at me. Good job. 2 points for Howard. Thank you. Hey, if they give you a problem and they say, make this function continuous, okay? Vertical asymptotes are not involved. There's not an easy way to take a function that has a vertical asymptote and get rid of it in a simple way with just a constant. With a jump, it's easy. You have a formula here and you have a formula here. You adjust the formulas a little bit, you can make them connect. It removes the discontinuity, it removes the jump. With a removable discontinuity, it's even easier because you've got, like, removable means the left and right limits are the same, just the point in the middle is in the wrong place. You just got to get the point in the middle to be in the right place. So where's the point in the middle right now? Like when we get close to 7 from the left, the y-coordinate's 2. Keep track of the fact. Don't lose track of the fact that we're always talking about x's and y's. Okay? Don't just do the problem. Think about it. When x is almost 7, what's y? 2. When x is a little more than 7, what's y? 2. So what in the freak? Is that the right word? Okay. I don't want to be inappropriate. I trust Lauren to not let me say something that would be inappropriate, especially on the video. Okay. So what in the freak should the y-coordinate be when x is 7? 2. So what's a? 2.
So you're not when these 2 gave us 2, and so basically when it is 7.
So here's the difference. So listen, hey, point for Justin. Listen. Okay, tease Calvin a little bit. I'll do the same to all of you. You don't say this, ever. Well, you know, here and there it's okay. For this class, you're going to be really specific. So it's really dangerous to say things like, oh, so, no offense, okay, but it's really dangerous to say things like, oh, to solve these kinds of problems. Oh, right there, you. Really, don't do that. There are no these kinds of problems on the AP test. There's just problems. And you solve a problem by understanding the problem. So I'm summarizing here because I got a minute. The key summary is we're supposed to make it continuous. Okay? There's different ways to approach the problem. The approach I took was I know darn well if I factor I can see better. So I factored. I saw a removable. Then I remembered I can get rid of a removable discontinuity. I can get rid of it. If I can just find out where it is. I know it's at x equals 7, but what's the y-coordinate there? Oh, it's 2. So I just need a dot right in the middle. It's also at 2. That's what this is for.
Okay.
Good work. Good job. That was there we go. Perfect. We're up. The answer is A equals 2.